Welcome to the class. Today let us start the topic fuels and combustion. As we know that in power plant, boiler converts into the steam. To convert the water into steam, we need to supply heat energy. The heat energy comes from when we burn the fuel, it generates a heat energy. That energy is supplied to the boiler to convert the water into the steam. Generally in boilers, we may use solid fuels, liquid fuels. Sometimes we also use gaseous fuels. Now let us see different types of fuels one by one. Classification of fuels: solid fuels, liquid fuels and gaseous fuels. Let us start with solid fuels. Several types of solid fuels are available, but let us discuss some important solid fuels which are generally used in industries. The first one is wood. You can see it in this figure. This is the wood. It consists of carbon and hydrogen. It can be converted into coal when it burned in the absence of air. Generally, the average calorific value of the wood is 19,700 kilojoule per kg. Calorific value means amount of energy released by complete combustion of 1 kg of fuel. That is calorific value. We will discuss in detail in coming slides. At present, we will see just what is the value of the particular fuel. The other type of solid fuel is peat. Actually, it is the first stage of the formation of coal. It contains water content up to 30%. Calorific value is 23,000 kilojoule per kg. Here you can see in this figure, this is the peat. The other type of solid fuel is lignite or brown coal. So it is the next stage of the peat in the formation of coal. It contains 40% moisture and 60% carbon. Generally, in the coal, most of the energy releases from the carbon. So if the carbon content is more, it can release more energy. Particularly in lignite or brown coal, here the carbon content is 60%. Calorific value is 25,000 kilojoule per kg. Here we can see brown coal in this figure. The other type of coal is bituminous coal. It is the next stage of the lignite in the formation of coal. It has very little moisture, 4 to 6%, and carbon content 75 to 90%, which means, as we know that the carbon content increases, it can release more energy. And also you can see here calorific value 33,500 kilojoule per kg, which means it can release 33,500 kilojoule energy by burning the 1 kg of the bituminous coal. Here in this figure you can see bituminous coal. The other type of coal is anthracite coal. It is final stage of coal formation, which is generally used coal because it has carbon content is about 90% and with little volatile matter. If you observe the calorific value, it has 36,000 kilojoules per kg, which means when we burn the 1 kg of the anthracite coal, it can generate 36,000 kilojoules energy. The other type of coal is wood charcoal. It can be made by heating the wood with the supply of air and temperature not less than the 280 degrees centigrade. Generally, it is used for various metallurgical applications. Here we can see in this figure wood charcoal. The other type of solid fuel is coke. This is produced when coal heated for 42 to 48 hours in the absence of air in the closed vessel. This process is known as carbonization. As you can see in this figure, the coke color is dull black and it is smokeless. The carbon content is 85 to 90% and it has higher calorific value than the coal. Cokes are two types, soft coke and hard coke. If carbonization carried out at 500 to 700 degrees centigrade, that is called soft coke. If carbonization is carried out at 900 to 1100 degrees centigrade, that is known as hard coke. The other type of coal is pulverized coal. Actually, it is a low grade coal with high ash content. This coal is first dried and then crushed into a fine powder by a pulverizing machine. Here you can see in this figure, this is a crushed powder. This is widely used in cement industries and metallurgical processes. The other type of fuel is liquid fuels. As of now, we discussed different types of solid fuels. Now, let us discuss about liquid fuels. Actually, liquid fuels are derived from crude oil. Crude oil, also known as a natural petroleum. Crude oils are obtained from boreholes in the earth crust, and it consists of a hydrocarbon. Petrol, kerosene, fuel oils and other lubricating oils are separated from crude oil at different temperatures and subsequent distillation processes. The other process of petroleum refining is the cracking. In this process, heavy carbon molecules are broken up into lighter molecules by means of heat and usually pressure. So this process is known as cracking. The other type of liquid fuel is petrol or gasoline. Petrol, also known as a gasoline. Petrol is the lightest and most volatile liquid fuel. Generally, it is used for light petrol engines. As we discussed in previous slide, we have to separate the petrol from crude oil at a different temperature and particular pressure by using a distillation process. So, generally, petrol distilled at a temperature range from 65 to 220 degrees centigrade. The other type of liquid fuel is kerosene, and it is also known as a paraffin oil. Actually, it is a heavier and less volatile when compared to the petrol. Generally, kerosene is used for heating and lighting fuel. Kerosene distilled at a temperature range of 220 degrees centigrade to 345 degrees centigrade. The next type of liquid fuel is heavy fuel oil. These type of fuels are distilled after petrol and kerosene, and it is generally used in diesel engines and in oil-fired boilers. It is distilled at temperature range of 345 to 470 degrees centigrade. So you can see here in this figure. So this is the heavy fuel oil. We have seen solid fuels and liquid fuels. Now let us see gaseous fuels. These type of fuels can be found in petroleum fields under Earth's surface. This type of fuels generally consists of methane and other gases such as ethane, carbon dioxide and carbon monoxide. First type of gaseous fuel is coal gas. It is also known as a town gas because generally it is used for town lighting or domestic lighting. That's why it is called it as a town gas. It is obtained by carbonization of coal, which means carbonization we already discussed. Carbonization means heating the coal for 42 to 45 hours in the absence of air in a closed vessel. The process is known as carbonization. Okay, so by carbonization of the coal, we can obtain the coal gas. It consists of hydrogen, carbon monoxide and various hydrocarbons. The calorific value of the coal gas is 21,000 to 25,000 kilojoule per meter. Next type of gaseous fuel is producer gas. This type of gas can be obtained by partial combustion of coal and coke anthracite coal in a mixed air steam blast. Generally, it is used for furnaces, gas melting and power generation. The calorific value of producer gas is about 6,700 kilojoule per meter. The other type of gaseous fuel is water gas. This gas consists of carbon monoxide and hydrogen, and it is made by passing steam over incandescent coke. As you can see in this figure, so this is the coke. Over the coke, air and steam will flow, and after flowing over the coke we will get the water gas. Here through this holder they collect the water gas. Now let us see other types of gases fuels such as Mond gas, blast furnace gas and coke oven gas. Let us see one by one. Mond gas. It is produced by passing air and large amount of steam over waste coal at temperature of 650 degrees centigrade. It is mostly suitable for gas engines. The calorific value of Mond gas is 5850 kilojoule per meter cube. Now blast furnace gas. Actually it is a byproduct of in the production of pig iron. While making pig iron, blast furnace gas will come out along with the pig iron in the blast furnace. It serves as a fuel in steelworks and also for steam raising in boilers and for preheating the blast furnace. The calorific value of blast furnace gas is 3750 kilojoule per meter. The next type is coke oven gas. This is also byproduct from the coke oven. It is obtained by the carbonization of bituminous coal. So we already discussed about bituminous coal. This is a type of solid fuel. When we carbonize the bituminous coal, we will get the coke oven gas. The calorific value of the coke oven gas is it is varies from 14,500 to 18,500 kilojoule per meter cube. Now let us discuss calorific value of fuel in detail. Calorific value, also known as a heat value, the amount of energy produced by the complete combustion of 1 kg of fuel is known as calorific value, which means by burning the 1 kg of fuel, the amount of energy released, that is called calorific value. Generally, it is expressed in terms of kilojoule per kg for fuels, and for gaseous fuels, it is expressed in terms of kilojoules per meter cube. Calorific values are two types: gross or high calorific value. The other one is net or low calorific value. Let us see one by one in detail. Generally, fire requires three components. Those are combustible materials, relevant temperatures, and sufficient oxygen. Which means when combustible materials mix with oxygen at particular relevant temperature, there will be combustion. Coal contains two types of components. Those are combustible components, non-combustible components. Combustible components are hydrogen, carbon and sulfur. Non-combustible components are oxygen, nitrogen, ash and moisture. Now let us see, after complete combustion of combustible components, those are carbon, hydrogen and sulfur, it will convert it into CO2, H2O, SO2, because this carbon reacts with the oxygen, it will give CO. Same way, when hydrogen reacts with the oxygen, it will give H2O, and sulfur reacts with the oxygen, it will give SO2. If you take the particular state at 25 degrees centigrade, it may have CO2 gaseous, SO2 gaseous and H2O liquid state. So it is called as gaseous gross calorific value or high calorific value. If you take the some other state at some other temperature, at that particular temperature it may have CO2 in gaseous state, SO2 in gaseous state, H2O in vapor state. So which is known as net calorific value or lower calorific value. Calorific values are two types, gross calorific value and net calorific value. Generally, higher calorific value always greater than the lower calorific value. Now let us see how to find gross calorific value and net calorific value. Before going in detail, let us see, if you burn 1 kg of carbon, it will give 8.1 into 10 power 3 kilocalorie energy at 25 degrees centigrade 1 atmosphere. Same way, when we burn the 1 kg of hydrogen, it will give 34.16 into 10 power 3 kilocalories at 25 degrees centigrade 1 atmosphere. If you burn the 1 kg of sulfur, it will give 2.24 into 10 power 3 kilocalories of at 25 degrees centigrade 1 atmosphere. So we know that carbon contains combustible components and non-combustible components. So there will be reaction only when combustible components are reacted with the oxygen. So to find the gross calorific value, we have to add all three combustible components and their energies. So if we take the gross calorific value, 81% carbon plus 341% hydrogen minus percentage of oxygen divided by 8 plus 221.5 kilocalorie per kg. Please note that this equation is in terms of kilocalorie per kg. To find the net calorific value, gross calorific value minus 5.84 into 9% of hydrogen plus percentage of moisture. The answer would be in terms of kilocalorie per kg. So these two equations are known as Dulong's formula because he invented these formulas, so it is called as a Dulong's formula. The same equations, if you take in terms of kilojoules per kg, the equations would be Gross calorific value equals to 339 percentage carbon plus 1427 percentage hydrogen minus percentage oxygen divided by 8 plus 92 percentage of sulfur. Here directly we substitute the percentage of the carbon value, percentage of the hydrogen value and percentage of the sulfur value to get the gross calorific value in terms of kilojoule per kg. Same way, to find the net calorific value, gross calorific value minus 24.44 into 9 percentage of hydrogen plus percentage of moisture. Here also we directly substitute the value of percentage of carbon and the value of percentage of moisture to get the net calorific value in terms of kilojoules per kg. So using these above equations, we can find the calorific value and net calorific value in terms of kilocalories per kg or in terms of kilojoules per kg. Okay, today we have seen different types of fuels. Those are solid fuels, liquid fuels and gaseous fuels, and also we have discussed about calorific value. Calorific value is the amount of energy liberated by burning 1 kg of fuel, that is calorific value. Okay, with this I am stopping here. Next class we will solve some problems on gross calorific value and net calorific value.